Hi there, I'm Frank Machado,
And I'm Curtis Andersen.
and today we will be presenting on the Lotka-Volterra predator-prey model. The Lotka-Volterra predator-prey model states that x prime is equal to ax minus bxy, and y prime is equal to cxy minus dy, where a, b, c, and d are all parameters. Our group mates were responsible for solving the equilibrium points of this model, and they, while setting x prime and y prime equal to 0 and doing a little bit of algebra, found that our two equilibrium points for this model are the origin, 0, 0, and the point d over c, comma a over b. Curtis and I were tasked with solving the Jacobian for this model, and we found that the Jacobians for the 2 points are at 0, 0, a 0, 0, negative d, and at d over c, comma a over b, the Jacobian was 0, negative db over c, and ca over b, comma 0. So, trying to analyze exactly what these Jacobians mean, we solved the trace and determinant for them, and then plugged those into our handy-dandy trace, determinant, and plane that we pulled out of our back pocket. And we're able to find that the determinant for the point 0, 0 is negative a over d, and the trace is a minus d. So this told us that the origin 0, 0 is a saddle when a is greater than 0, and it's a degenerate source or sink depending on who's greater between a and d. As for the point d over c, comma a over b, we found that when the product of ad is greater than 0, the point is a saddle, and when it's less than 0, the point is actually a center. And on the off chance that a or d equals 0, the product of AD would also then be 0, and we would have a degenerate point.
Okay, so for this project we were tasked with finding two species that interacted in the same way that the model displays. Now, in order to do that, we decided to look at the history of the model. It started out as a chemistry model by Lotka, and then through many mathematicians later it became adapted by Volterra as an actual species model. He looked at the interaction between foxes and rabbits in Europe at the time, so we decided what better spot to look than the original species that were used, foxes and rabbits. But the equation was made quite a while ago, so has human interaction changed the way the species interact?
Yeah, so that was actually about 100 years ago, right?
Yeah, it was roughly around 100 years ago.
So we decided to do some research and find a more modern application of the model. So what we found was the Environmental Protection Agency of British Columbia had done some research on foxes and rabbits and their population, and they used the Lotka-Volterra model, actually. And they did their research in about 2012, which was pretty recent, considering the population cycle for both foxes and rabbits is roughly 8 years. For foxes, the gestation period is 7 to 9 years, and 8 to 10 years, and the population for foxes is 8 to 10 years. That makes sense because rabbits tend to populate a lot faster than foxes do. Their research of British Columbia found that for a radius of about 10 square kilometers area, the high population for foxes was about 10 and the low was 1, whereas for rabbits the high was about 250 and the low was only 60. So, Curtis?
Alright, so this graph illustrates the loop that would occur if you had foxes and rabbits in the overall area of 10 kilometers. The loops change depending on how many you start with. So the 10 and 1 for foxes was the extremes. Normally it's about somewhere in the range of like 5 to 6, the basic average. But this graph doesn't make sense to most people. These ones are the ones people care about, with the upper line being for the rabbits and the lower line being for the foxes. Do you want to talk about the next graph?
Yeah. So the model states that the 4 parameters A, B, C, and D are the high and low population points for the foxes and the rabbits. So as you can see here, the blue line being prey and the red line being predator, The blue line is much higher, which makes sense because there tends to be a lot more rabbits than there are foxes. So we were able to formulate this graph based on the research that the British Columbia website had given us. So we plugged in the high population for foxes 10, the low population for foxes 1, the high population for rabbits 250, and the low population 60. And we got this graph, which is pretty sensible. There you can see the cycles as it goes and moves through time. According to the British Columbian website's research, they took their data in 2012, which they stated was a high point for fox population, so somewhere around here. And that estimates to us, based on their cycle estimated time, 7 to 9 years, that around 2019 we should expect to see a jump in the rabbit population.
Now, this is very important because it has to do with the trapping and all of that stuff for British Columbia. So the research on this is actually very, very good because it is a large part of their economy up in the northern area of Canada. And yeah, that's the Lotka-Volterra model.
Yeah, it was pretty exciting to find out that 100 years later, after the model's first application, even with all our modern day changes in the ecosystem and hunting and such, the model is still pretty accurate.
Yes.
All right, thank you.
Thank you.